and for the gift of life, the gift of learning. Please open our mind to understand the lesson, guide our thoughts, and help us pay attention. Give your give our teacher wisdom to explain well and help us remember what we learn. Keep us focused, respectful, and eager to gain knowledge. Amen.
Amen. Thank you so much, Sobra, for the word of prayer. Good morning once again. Thank you so much for keeping time. We are good to start. So, we are still continuing with our curve sketching, and in this particular lesson, we are going to continue looking at curve sketching. Yesterday we looked at some things, and today we are going to build up from there, and then we continue. So today we are going to start with how do we find the region where the curve lies? Now, when we are making a sketch, these ones being rational functions, we need to know where will our curve lie. Now, when we talk about our curve lying here, we basically looking at, you know very well that when I have, this is my y and this is my x-axis. Now, if this is my y-axis and this is my x-axis, I need to know, is my graph going to be above the x-axis? Is it going to be below the x-axis? So now, by finding the region where the curve lies, we are asking ourselves, is it above or is it below the x-axis? And now, how do we do it, or how do we find where that region lies? Or how do we know that our curve is either below or above the x-axis? If I have my function y is equal to, this is the polynomial written in terms of x, and I have another polynomial written in terms of x, whereby where our this x of ours is not equal to 0. So what do we do? Always we get the polynomial. In order for us to find that region, we get our polynomial of x, we equate it to 0. We get our polynomial of q, we also equate it to 0. So we solve out these ones, and then we use that table to come up with a solution. So what you need to know is that when it comes to the region where the curve lies, it means that for your y, when you get your y greater than 0, it means that your curve here is going to be above the x-axis. If your y is less than 0, then it is an indicator that you are below the x-axis. Now, for you, look at the values of y you have got. After evaluating your polynomials here, if your y is greater than 0, then it means it is above the x-axis. If it is below the x-axis, you'll find your answer as a negative. Should we look at an example? Let me know. Should we look at an example? Okay, so we are going to look at an example. This is our first example that we are going to look at. What do we do? Now, in order for us to come up with a region where the curve lies, I'm going to say my x minus 2 is equal to 0. That is the numerator, meaning that my x is equal to 2. Then also I'm going to say that my x minus 1 is equal to 0, and therefore your x will equal to 1. Now, what do you do? I always encourage us using a number line, such that you know where your x values are. So in my number line, like the way you see, I have 1, and then I'll have 2 here. Now, when we are obtaining the x values, we get the values below. These are values that are less than 1. We get the values in between here, which is between 1 less than x less than 2. But also we consider the values that are above, which is x greater than 2. So we are going to do it the way we did it yesterday, whereby we are going to say our x is less than 1. This is negative 2. I don't know why I have. This is negative 2. This is plus 2. Oh, I have to change. Okay, allow me now to first, I didn't see it coming. Yeah. Okay, allow me to repeat, and then, so this is x plus 2 is equal to 0. So your x will equal to negative 2. Then we have x minus 1 is equal to 0. So your x is equal to 1. Now, when I am on my number line, I'll label. I have my negative 2 here, and I know my 1 will here. So I will consider the values that are less than 2, are less than negative 2. Then I look at the values in between, negative 2, less than x, less than 1. Then I'll know what about values that are above 1. In other words, you are trying to get how does our function, how does our curve behave in those regions for those different values of x. So I'm going to come here, and then I'll say, I have my simple table. In my simple table, in the simple table I have this region whereby x is less than negative 2. I have this region whereby I have negative 2 less than x less than 1. And I have this region which is above the 1. Now, we have to fill it in the first one, which is x plus 2. Then we need to know how is our curve when we have x minus 1. What about the final one, which is y? So y is x plus 2 divided by x minus 1. And it's like yesterday I said, you can feed it there, there, and there. There's no problem for you to break it. So here we can use two approaches. You can either break it or use it at once. So when I have any value less than negative 2, an example I can have is negative 5 here. So here when I say negative 5 plus 2, I'll end up with an answer that is a negative. When I say between negative 2 and 1, 0, you end up with your answer as positive. Any value above 1, you get positive. So when I come to the next one here, when I put any value less than negative 1, say I have put negative 3, I'll have negative 3 minus 1, I end up with negative. Any value between negative 2 and 1, say you have put 0. When you put 0, you get a negative. Any value above 1, we shall have a positive. An example, you can say 5 minus 1. Now, since we are dividing, the 2 shall have divide this one divide by this, you get a positive. Positive divided by a negative, you get a negative. Positive divided by a positive, you end up with a positive. Now, this is how your table will look like. That is how your table will look like. That here you have a negative, you have a positive, negative, negative, positive, positive, negative, and then positive. So that means that when you draw your curve, you come up with this kind of sketch. You'll find that where you have the values of any value less than negative 2, your curve is going to be below. When it is between negative 2 and 1, it's going to be below negative. Sorry, for positive, it is above. Where you have negative, it is below. So in case you have your x-axis, this is our y and this is x. For positive, your curve expected to be above this side. Negative, your curve is going to be below. Allow me to show you practically how this one will look like, and then you visualize how those curves will look like. So in case I come here, I want to plot that curve. So when you plot that curve here, you're going to have y is equal to x plus 2 divided by our x minus 1. What does that mean? Oh. So when you look at when you look at the sorry, when you look at our curves, okay. When you look at our curves, I want you to look at them very well. Okay. Let me write y equals to it has been x plus 2, then x minus 1. When you look at our curves, like I've said, when you remember our table we had x less than negative 2, we had between negative 2 less than x less than 1, and we had our value greater than 1. So here we had a positive, negative, and positive. So between any value less than negative 2 of x, this is where we have negative 2. It is going to be positive. So that means your curve is above the x-axis. That's why this part is above the x-axis. Then between negative 2 and 1, the value is negative. So it's going to be below. So that's why between negative 2 here and where you have your 1, any part of the graph you are getting, it is coming below or it is below the x-axis. Then anything above 1, your curve is going to be in the positive. So anything that will come this side, our curve is above the way you see it this side. It is only above the x-axis. Members, let me know whether we have understood that part. Is that part okay? Are we on the same page? Okay, Linda says yes. Yes. Yeah. Okay. Good. 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 Yeah. So that's how our curve will behave. Okay. We can have another example. Take an example, we have this where we have quite a number of them. Still, we do the same thing. Equate, say, x minus 1 is equal to 0. Your x will equal to 1. Then x minus 9 is equal to 0. Your x will equal to 9. Go to the denominator. X plus 1 is equal to 0. Your x will equal to negative 1. Then x plus 9 is equal to 0. Your x is equal to negative 9. What do you do? Put them on the number line such that you know how it will look like. All those values of x. So when you look here, you notice I have negative 1. On a number line, we shall have negative 9 here. On a number line, you have a 1 and then you have a 9. So what does it mean? I'm going to get a value that is x less than negative 9. I get between negative 9 less than x less than negative 1. I get between negative 1 less than x less than 1. Then I get between 1 less than x less than 9. Then also I get what about above 9. So I read all the different sections such that I know when our values of x are below negative 9, how does our curve behave? What about when it is between negative 9 and negative 1? So I'm going to draw our table here. In our table here, I'm going to come and I say, I have a value below negative 9. I have a value between negative 9 less than x less than negative 1. I have a value between negative 1 less than x less than 1. I have a value between 1 less than x less than 9. I have a value that is above the 9. Now, after getting those values, I'm going to come back and say, what things do I have? I have x minus 1 and x minus 9. So it is okay, I can first put them together, x minus 1, x minus 9. Also, I have x plus 1, x plus 9. I have it like that. I have it like that. And then I'll have my y. Then choose a value that is less than negative 9. Say negative 10. Put it here. Negative 10 minus 1 is negative 11. Negative 10 minus this is also a negative 20. Then say negative times negative, I get a positive. So that means here we shall have a positive. Then say between negative 9 and negative 1, any value in between, say negative 5. Put it here. So you'll have negative 5 minus 1, which is negative 6. Negative 5 minus 9, the answer is negative. Negative times negative, you get a positive. What about between negative 1 and 1? I will take 0. So this will be 0 minus 1 and 0 minus 9. This is negative and negative. Negative times the negative, I get a positive. Put any value between 1 and 9. Say 8 is here. 8 minus 1 is a 7. 8 minus 9 is a negative 1. So positive times a negative, you get a negative. Any value above 9, say 20. 20 minus 1, 20 minus this, you get a positive value. Then come here. Any value less than -9, say -10. Say -10 plus 1 is the negative. -10 plus 9, you get also a negative. Negative times the negative, you get a positive. What about between -9 and -1? Use any value, -5. -5 plus 1, you get a negative. -5 plus 9, you end up with a positive. So negative times a positive, you get a negative. Then negative and 1, put a 0. 0 and 0, here you get a 1 and you get a 9. So you end up with a positive. Here you end up with a positive and you end up with a positive. But remember, you are dividing the two. So positive divided by positive, you get positive. Positive divided by negative, negative. Positive, negative, and then the positive. So your table will look like that. Now that one shows you where is my graph going to be above and where it's going to be below. So when we go back and we look at the final sketch after you have come up with these values, you will notice that your sketch will look like this. It will follow this positive, negative, and then positive. So if I go back and I show you graphically here, uh, we had x, it was x minus 1. This is one bracket. Another bracket was x minus 9. Then this one down was x, and this was a plus, and then we had another bracket, x plus 9. So when you look at that curve after sketching, your curve will look like that. I'm going to minimize it such that you can be able to see all those graphs. So I have minimized it, but this was the one, not 21. Eh. So when you look at it, I've minimized it such that you can be able to see all the graphs. So you'll see that we have 4 graphs. But when you look at the pattern, let me now make it bigger such that you can be able to see it. Now, when you look at the pattern, you'll notice that, like we have said, that anything that was below was above our -1. When you go back here, anything below -9 was a positive. So when you look at this curve, when you look at anything below positive, -9 here was a positive. That's why your curve is up here, because it was below. And you notice that anything that was between -9 and 1 was a negative. So when you look at your curve here very well, between -9 and -1, it is below the axis. When you go back and look at the behavior between -1 and 1, here it was up. Between 1 and what? And 9, if you try to, when you move this curve here, between 1 and 9, you'll see that your curve between 1 and 9, you'll notice that your curve was below, negative. Anything above 9, the curve went up. Now, in sketching, that idea must come out very well. When you are making your sketch, you are coming up with the final sketch of your graph, then those things must appear very well. Members, let me know. Are we together? Yes. Okay. Sabra says yes. Gilbert says yes. Linda says yes. Nice one is okay. Trisha, okay. Okay. I think Nawire is okay. Very good. Very good. Okay. Okay. Kathy is okay. Okay. Since we are very fine, allow me the other screen, which no. Now here we stop at that point and then we show it on a graph. We show it on a graph, Abby. Okay, now I'm going to request you that these are the steps. We have gone through all the steps we need when we are making a sketch. of any curve. And allow me that I invite you to take note of these steps. What you need to know. One, you need to know the intercepts, the asymptotes, the turning points. You must know here, you can call it the nature of the turning points, or finding the nature of the turning points here, finding the nature of turning points, the nature of turning points, finding where the curve lies, finding where the curve doesn't lie, and then lastly, sketching. Now, these are the steps we are going to go through to come up with our graph. But let me ask you, can you first put them down and then we continue? Yes, shadow, it is very possible for that for such numbers to be set for such graphs. Mhm. Yes, Sabra.
Good morning, teacher.
Morning.
Teacher, now a teacher they ask you a question. For
Mm,
example, they give you an equation, they tell you 2x minus 5
mm,
divided by x plus 1 is
mm,
equal to x plus 3 over x minus 2. Then they tell you to state any restriction on the domain. And then
2x minus 5 out of
it is 2x minus 5 out of x plus 1
mm,
equal to x plus 3 out of x minus 2.
mm,
Then they tell you to find any restriction on the domain of the equation.
mm.
And then
Remind
last,
us, what did we say about the domain yesterday?
like the domain lies on the x-axis.
That is true. That is one. Two.
Then also, when you are finding the domain, okay, there is some what should I say?
What did we say about the denominator?
The denominator,
Mm,
equal the denominator. Hmm, hmm.
We said that this one, Sobra, and these
Yes.
ones can never be equal to those particular. So you just say x plus 1 cannot be equal to 0. So the restriction should be x should not equal to negative 1, and also x minus 2 shouldn't equal to 0. So x should not equal to 2. So these are the restricted values for your domain.
Mm-hmm.
Hmm.
Okay.
Then other values of x hold.
So thank you.
Because once you put here 2, your equation becomes meaningless. Once you put here negative 1 here, your function becomes meaningless as well. Okay.
Teacher, thank you.
Okay. Uh-huh. Okay. Okay. I think we are good to continue. Are we good to continue, members? Husna, have you finished? Okay. I think from the chat, members are saying we can. No, domain, Julia, is the set of all x values. The domain is the set of all x values. When they ask for restriction, which values of x do not satisfy that equation that you are dealing with? Okay, so we are going to start with this one, which is the curve we are going to sketch. Now, like we have said, we are going to fall through different steps. So you're going to allow me, we break those steps. The first one, we are going to look at finding the intercept. So I'm going to say finding the intercept. Now we say that an intercept is that point where your curve cuts the x or the y axis. So when we start with the first one, what we call the x-intercept. When I talk about the x-intercept, members, what do you know? Put in the chat. X-intercept, what do you remember about x-intercept? What do we need to equate? How y is equal to 0. Very good. So for x-intercept, our y is equal to 0. So when you look at our curve, I'll have my y equals to 1 out of x plus 1. So when our y here is 0, I'll have 0 equals to 1 out of x plus 1. So here I cross multiply. So I'll have 0 times x plus 1 equals to 1. So 0 is equal to 1. Now, for such a case where you get such an answer, it means that there is no x-intercept. Now, for such, because you have the value of y, but you don't have the value of x. So here you conclude that there is no x-intercept. Then you go to the y-intercept. We say that for the y-intercept, it means that our x is equal to 0. So our equation is y is equal to 1 out of x plus 1, which gives us a 1 out of 0 plus 1, which gives us a 1. That is our y. And therefore, our intercept is going to be 0 and 1. Now, after getting this, we go to the next one, what we call the asymptote. And we say that when you're finding the asymptote, be very careful. Which kind of asymptote do you have? We said we have a vertical, we have a horizontal, and we have an oblique. But always the first one we start with is the vertical asymptote. Why? When it comes to the vertical asymptote, it is just a matter of us equating what we have in the denominator. Because we said for a vertical asymptote, your denominator is equal to 0. And therefore, we shall say x plus 1 is equal to 0. Our x is equal to -1. Then we ask ourselves, the next one, are we getting a horizontal? Are we getting an oblique? Put for me in the chat. Which kind of asymptote are we getting? Is it oblique? Is it horizontal? Put in the chat. Ayobo has said it is horizontal. And members, what do we base on to say that it is horizontal or it is oblique? Horizontal. Someone to tell us just why have you concluded that it is horizontal? What is it that you have looked at and said this is an horizontal asymptote? What is it? What did we say about that? That in order for you to know it is horizontal, thank you, Shadow. Shadow said the powers. Shadow said the powers. Nawir has also said the powers in the fraction. When you look at the fraction here, you look at the numerator, look at the denominator. The highest power here is a 0 because here there is an hidden x. The highest power here is a 1. And therefore, we said when the denominator's power are greater than the numerator's power, then we can say that that one is a horizontal asymptote. So now we are going to come and say, here our asymptote is going to be what? So we shall come and say, now our horizontal asymptote. What is it going to be? Remember we said that for horizontal asymptote, our x will always tend to infinity. And we said that the moment you find that the denominator, members, is... are we safe, Ayobo? Ayobo, are we safe with your response? So we say that... Oh, okay. I think Ayobo was explaining. Now, for such a case, if you do it practically, it means your y will equal to 1. Our x is infinity plus 1, which is the same as having 1 out of infinity. And 1 out of infinity is 0. So your y is equal to 0. So we say that always the moment you see that the denominator's power greater than the numerator, always your asymptote will be as 0. Okay, now after finding that one, there is no need to check whether we have another asymptote. Then after asymptotes, we go to the next one. The next one we are going to find is going to be our turning points. And now to get our turning points, what does it mean? It means that we need now to get our dy dx. So our function, I can write it as x plus 1 power negative 1. So I get my dy. My dy dx will equal to negative of x plus 1 power negative 2, then times a 1, which I can ignore. So we shall have negative 1 out of x plus 1, everything squared. This is our dy dx. And we say to get the turning points, at turning points, we know that our dy dx is equal to 0. So where we have our dy dx, we equate to 0. So 0 will equal to negative 1 out of x plus 1 squared. When you cross multiply, you get 0 times x plus 1. Everything squared is equal to negative 1. 0 times this, you get 0 is equal to negative 1. Members, what's going to be our conclusion about the turning points? Aha, thank you. What is your conclusion? How are you going to conclude there? What will you have done at that point? Aha, Ayoba has given an answer. Yes. So at such a point where you are not finding the value of x, you just say that we have no turning points. And since you don't have no turning points, you stop at that point. Then the next thing you go on, you ask yourself the range. Do you know where the range is for your values, or the region where the curve doesn't lie? Now, for that one, we only find it if the curves we have here are quadratic in nature. But this one being a non-quadratic function, here your polynomials are not quadratic. There's no need for us to find a region where the curve doesn't lie. Because for such a case, we know that our range, the range of values here, the range of values, we shall have all the different, we shall have different what? Different values. If you are to find the domain, we know that the domain contains all the x values. So here the only other thing we need to know is the values, we need to just know where does our curve lie, region where the curve lies, region where curve lies. So here it means we shall just say x plus 1 is equal to 0. Our x is equal to negative 1. So that means that in your table, you just have just one thing. I have this, whereby this is my y. So values here, it means that in case you are using your number line, here you get a value less than negative 1 and a value that is above negative 1. A value less than negative 1, take an example, negative 4. When you get negative 4 and you here negative 4, let me say I've taken x is equal to negative 4. It means our y will equal to 1 out of negative 4 plus 1, which is 1 out of negative 3. So here you get your answer as negative. What about a value above negative 1? An example, I can take 0. When x is 0, our y will equal to 1 out of 0 plus 1, which is a 1. So here you get a positive value. And now, once you have all those, it means you can go on and draw your curve. But may I know whether we have understood up to that point? Up to that point, I want to know whether members have understood all those different things we have obtained. Okay, good to go. Why are we saying x is equal to infinity? We are looking at the behavior of the curve as it approaches that particular value. On the last part, Paul, which is what is confusing. Remember here, Paul, we say that to get the region where your curve lies, just equate the numerator and the denominator to 0. So when you equate the denominator, your x is equal to negative 1. So you want to find out how does our curve behave between when you have negative 1, either below it or above negative 1. So this is how we obtain the behavior. So what I'm going to do is I'm going to go to my book, but because I want to be accurate, you will allow me to use a graph. You'll allow me to use a graph. So on my graph here, I'm going to draw. I want to be very accurate such that you can see how our curve looks like. So This is my thing, and this is my thing. Yes, but when you are doing this, you may not necessarily use a graph. You may not necessarily use a graph. But I'll have 0 here. I'll have -1. I'll have -2. But I want to be accurate. And if you want also to be accurate, you can use your graph. So here I'll have 1. I'll have 2. I'll have 3. I'll have 4. And I'll have x. I'll come here and say this is my 1. This is my 2. This is my 3. And this is my 4. -1, -2, -3, and then -4. Now, what you do, you start putting each point you have obtained. But always, my direction is, I'll first come to my graph. I go back to my table. What do I need to plot? One, we have the intercept. Y-intercept is 0 and 1. So that means when I go on my graph, I'm going to take note of that point, 0 and 1. So let me use maybe black, 0 and 1 here. What does it mean? Our curve must touch this point and intercept. It means our curve must touch it. I go back to another thing I'm supposed to get. Another thing I'm supposed to get, you notice that we had a vertical asymptote, x is equal to -1. Now I'll come here and I say x is equal to -1. This is -1, so it should be a vertical line. So I'm going to come here and then I'll draw that vertical line in that form. Oh, yours should be a good one. That is our x is equal to -1. Why is it dotted? Because we say that our curve doesn't touch the asymptote. So this is x is equal to -1. I've said it does not touch the vertical asymptote, though it can cross the horizontal asymptote. For horizontal asymptote, it can cross it, but it does not touch the vertical asymptote. Then when it comes to vertical, we also had this one here. Y is equal to 0. So y is equal to 0 is there. So this is our y is equal to 0. Now after that, we are going to go on and see whether we have any other thing. We are going to go on and see whether we have any other thing. Remember, we had no turning points, so we don't need it. And then the region, we notice that below -1, our curve is below. Above -1, it is above. Now, what do you do? I'll come back here on my graph. Now, our nature of the curve is that below -1. This is where we have -1. Hope everyone can see it. Below -1, our curve, like they have told us, it is below. Meaning that I have region A here, I have region B. Below -1. Now, where do you think our curve is going to be? Is it in region A, in region B? For that part, where do you think our curve is going to be? Aha, very good. It's going to be in the region B. Now, for such a case, members, remember this is an asymptote, this is an asymptote. But like we have said that below -1, the curve is below. So that means that it will not touch this asymptote, it will not touch this asymptote. So members, what you do, you just come and you draw your curve. Let me get a, hey, who's this one? That in our work. So what you do, you just come on this graph of ours. Let me use maybe this color. Okay, I can use this. You just come here. It does not touch the horizontal. It does not touch. Then you draw something like this. That's how you draw your curve. Does not touch this one, does not touch this one. Then above a 1, our curve is above. So meaning that it's going to be here above the x-axis. However, it should touch 1. It should touch 1. That means that our curve will come like this. It comes like this. It touches that point, the intercept. Then anything above 1, our curve must be above. So anything, we remember we said anything above -1, our curve is above. So that means it will not touch this x-axis. It will just come and it does like that. And and then it stops there. So that's how you sketch your curve. Yeah, in case you have a question, ask at this point. In case there's any question, and I want to tell you that is how our curve looks like. Any questions? Or we have understood? Members, have we understood? Okay, 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 perfect. Okay. Finalize yours and then we can continue. Yes, Baswal?
Good morning, teacher.
Morning.
Teacher, I can request you to sketch again.
Okay, which part? Which part? Because when we are sketching, we look at the behavior. When we were having x less than -1, our answer was negative. When we are having x greater than -1, we got a positive. What does it mean? It means that any below -1, your curve is going to be below the x-axis. So when you look at our region, this is below the x-axis. Here, when you look at it very well, you notice that, let me first, okay, remove this and this. You notice that below the x-axis, below the x-axis, you notice that here there is an asymptote, and we said our curve does not touch, though it can pass through the asymptote. And this is the vertical one. On the vertical, it should not touch and it should not pass through. Now, when you are sketching, since this is above the x-axis and anything below -1, our curve should be below. So your curve will look like this. It will behave like that along those asymptotes. As if this side it shows it is going to negative infinity. This side below it's going to infinity. Then when it came to here, since we had an intercept, our curve must pass through the intercept. But anything above -1, it lies in the positive region. So that means that anything you come up should be above the x-axis. So you draw your curve passing through that intercept. Something like that.
Okay, teacher, thank you.
Okay. Uh, is everyone now okay? Yes. Like Paul yesterday, if Paul you attended yesterday, I told you that what we call the region of restriction is the region where your curve does not lie. And we said to get that region, you restrict, you look at your range. You look at the range. Yesterday I explained it. I told you that the moment you have b squared minus 4sc greater than 0, the region of restriction is the region that will give you a negative. But we shall look at curves. Not all curves will have regions of restriction. Take note of that. And when we talk, so that one, you'll have to know it. Yes, you can put, we are going to have a title. We are going to have a title. We are going to have a title. So when they say region of restriction, that's where your curve does not lie. When they say what? An empty section, that is the region where no part of the curve lies. Eh, But we shall look at curves that bring out that idea. Not all curves will bring it out. There are curves that will not bring it out. Mm. Yes, Gilbert?
Yes, good morning, sir.
Morning.
Um, Sir, is there anything like labeling those curves, or we don't?
No, here you don't need to label. You don't need to do any labeling. But your sketch here, you can say a sketch of the graph y is equal to 1 out of x plus 1.
Okay, sir. Thank you.
All right. Okay, okay, okay. So, are we going to continue? Are we going to continue? Okay, good to go. Yeah, we can continue. All right. Oh, Okay. Let's look at this one here. Let's look at this one here. Eh, So I'm going to ask each one of you to first get the intercept. That is the first thing. Let everyone first get the intercept. Get the intercept. Get the intercept. From us. Go on to get the asymptotes. Go on to get the turning points. So let's keep on working. Go on to get the asymptotes, turning points. Let's be getting all those ones. Let's be getting all those ones. Mm. Okay, can I have one person to raise the hand and you take us through one of the parts? The rest you can continue, and the rest be continuing as I get Ayob. Okay, yes, Ayob.
Morning, sir.
Morning.
So we'll first begin by getting the asymptote, the intercepts.
Intercept.
So for the y-intercept,
Y-intercept.
we have y equals to 3
Y equals to 3
into 0
into 0.
plus 6
Mhm.
over 0 minus 1. So we have there negative 6, negative 6.
Negative 6, okay.
So when x is 0, y has to be negative 6.
Mhm.
And then for the x-intercept, you have y equals to 0.
Mhm.
So it becomes 0 equals to 3x plus 6 over x minus 1. So 3x plus 6 equals to 0. Then 3x equals to negative 6. Then we have x being negative 6 divided by 3 as negative 2. Yes. So the point is negative 2 and 0.
Yeah.
And then for the asymptotes,
Mm.
for the vertical, we equate the denominator to 0.
Yeah.
X minus 1 equals to 0. So it is x equals to 1. The vertical, then the horizontal, we divide that highest.
Mhm. Why and what have you based on to divide?
What I'm basing on to divide is among the rules.
Mm.
We can divide through everywhere by x, or we can just take the leading term and we divide it.
Okay.
X over x. So we have 3 plus 6 over x.
Mhm.
So where we have x, we put infinity.
Yeah.
Divided by 1 minus. So that all just becomes 6 plus 0 over 1 minus 0. So have the vertical asymptote as
Vertical asymptote? Oh,
the horizontal asymptote.
horizontal asymptote. Okay.
So there is that one's supposed to be 3, not 6.
Oh,
The,
this one.
yeah.
Okay. Mm-hmm.
Now for the turning point,
Okay, turning point.
we first take logarithms on both sides, which are log ln y equals to ln 3x plus 3 plus 6 minus log of x minus 1.
Okay.
So we have 1 over y dy, 1 over 1 dy equals to 3 over x, 3x plus 6 minus 1 over x minus 1 dx. So we put those things under common denominator.
Mm.
So we have 3x plus 6 multiplied by x minus 1. And up we have 3 multiplying x minus 1 minus 3x plus 6 dx. So we make dy dx the subject.
Mm.
We shall have, well, we open the brackets to have 3x minus 3 minus 3x minus 6 over 3x plus 6 multiplying by x minus 1, then also multiplied by y, which are 3x plus 6 over x minus 1. So all in all, we have negative 9 over x minus 1 squared.
Yeah.
For the turning point, dy dx has to be equal to 0.
Mm-hmm.
So we have negative 9 over x minus 1 squared equals to 0. So we just have negative 9 equals to 0. So we conclude and we say there's no turning point.
Okay.
So,
Okay. Okay. Okay, thank you, Asio. I think let's also have one other person to take us from that point. Thank you so much. So members, you confirm, can we have another person to take us from there to the next part? The region where the curve is going to be lying. Who is taking us through the region where the curve is going to lie? Okay, Sabra.
From our equation, 3x plus 6 is equal to 0.
Okay.
Therefore, x is equal to negative 2. Then x minus 1 is equal to 0. Then x is equal to negative 1.
Come
Is equal to
again.
1. X is equal to 1. Okay. From our y is
Mm-hmm.
3x plus 6 over x minus 1. Okay, in a table form, during the table to get the region where the curve lies.
Mm. So you put here y,
Mm.
or you want to separate them?
Uh-uh.
Okay.
Then we have x is less than negative 2. Then negative 2 less than or equal to x less than or equal to 1. Then x greater than 1.
Why do you say less than or equal to 1?
Where, teacher?
Or like you are saying less than or equal to 1.
Okay, it was just a slip of my tongue. I'm sorry.
Okay.
Then x is greater than 1.
Uh-huh. Yes. Okay, now why? In fact, someone else, Sobra, may do the same. You first tell me why you think it is not equal to 1. Why you don't put that thing? What do you think?
Because 1 is not inclusive.
Because 1 is not inclusive. Perfect. So the moment you put 1 here, your function does not make sense. Perfect. That's good. We continue.
Then if you put maybe -3 in our function,
Mm-hmm.
let me first put it there. It will be 3 times -3, which will be a -9, plus 6, giving us a -3 up, then over negative, giving us a positive.
Okay.
Then between -1 and -2 and 1, maybe we use 0. If we put 0
Mm-hmm.
in our equation, we get 6 over -1, giving us a negative.
Okay.
Then if we use maybe 2
Mm.
in our equation, that will be a 6 plus 6, giving us a 12, then over, giving us a positive. It gives us a positive.
Okay.
So
Good.
our it will be maximum.
Okay. Not maximum, as in, remember
Mm.
what these ones mean that between less than -1, your curve will be above the x-axis. Between -2 and 1, it will be below.
Mm.
Eh,
Okay.
o- Okay. Perfect. So now we are going to go here. So we draw our axis here. So I'm going to just roughly draw this. I draw this. Then from there, I'll come and I say, oh, this is my 0. This is my 1. This is my 2, 3, 4. This is my -1, -2, -3, -4. Our 1, 2, 3, 4. Our 1, 2, 3, and 4. Now, what does it mean? It means that when you look at this, you first have your points put there. So when you look at our curve, at our points, we got two intercepts, 0 and -6, and -2, 0. So I'll go back 0. I need to put a -6. So I'm going to shift a bit my lines such that I can accommodate -6. Anyway, let me remove everything. Because we have to accommodate it. We have to accommodate it. The -6 and then the -2 and 0. Okay, let me draw my line around there. Then I'll have, this is -1, -2, -3, -4, 0. This is -1, -2, -3, -4, -5, -6. Okay, still it's not fitting the way I would have wanted because I wanted you to see it very well. So allow me still to extend my graph a step above there. So -1, -2, -3, -4, 0, -1, -2, -3, -4, -5, -6. Then I have my 1, 2, 3, 4. Yeah. Then I have my 1, 2. So we had -2, 0 and 0, -6. So I'll plot those 2 points. -2, 0, this is 1. This is an intercept your curve must touch. And 0, -6, this. Your curve must touch those points in simple terms. Then number 2, we go back to the asymptotes. We had y is equal to 3 and x is equal to 1. So x is equal to 1 is this line here. Remember, it is a vertical line where your curve does not touch. So I'll come x is equal to 1. Use the ruler, draw your x is equal to 1. This is one of the asymptotes. Then our y is equal to 3. Our y equals to 3 is this asymptote here. Tan, 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 tan. This is our y is equal to 3. So when I extend a bit up here, this is your 3 here. Then, which other thing we need to look out for? When I go back, I'm going to have another one. When you look at, there is no turning point. So that one, I don't need it. So when I come back, I look at the nature of our graph. Less than -2 is the positive. Above -2 is the negative. So when you are drawing less than -2, we got it as, what was it? It was a positive. Between -2 less than x less than -1, it was negative. Then above, it was a positive. Now, here you be very careful as you are coming up with your sketch. Your curve must touch this point, but above -2, it should be above. Then below, between -2 and 1, it should be below. So when I'm coming up with my sketch, I'm going to come up with a sketch here. I'll say my graph asymptote, it just appears there. So I'll say it's going to come like this. It must touch this point. Remember, it must also touch this point here down. So it will come like this. It must touch the intercepts. Something like that. That's how your curve will look like. This side here, but between -2 and 1, it is below. Above that, it is positive. Then between above 1, your curve must be positive. So when you come here above 1, it must be positive. So what does it mean? You ask yourself, where should my curve be? Above. I don't know whether members are getting it, that your curve must be above. So remember, this is your intercept here. So above, your curve here, when I'm drawing the curve, I don't need to draw it here. I can look at this asymptote and this one, and then I draw something like that. That above, my curve should be positive. I draw something like that. As long as it does not touch the asymptote, it does not touch the asymptote. It will appear something like that. But I must show that kind of infinity, in other words. So I don't expect you to come and draw your curve like this. What does it mean? When you draw it here, it means it is going this side. But below 1 here, we said we should not have we should not have anything. So here it means your curve is indirectly going down. So here it does not lie. It does not make sense. So that's why we cannot draw it in this region. Let me hope members have understood that. Why we don't draw it here? The moment you do something like this one shows that it is coming from positive infinity going to this side. Yet our curve below here, it must always be above. So here it is like coming down. So here it should not be in that region. Okay, let me first pick a hand. Yes, Linda.
Sir, I'm lost from that part. Here, where I said the x-axis, it's less than -2. There I've got you. But this part where we have a negative, how
Between
does that
-2
come?
and 1. Between -2 and 1. This is where you have
Yes.
-2. And this where you have 1. Now, any sketch of the curve you are getting must be below. Negative means below the x-axis. Positive means above the x-axis. So
Okay,
that's why
thank you.
this part of the curve between -2 and 1 is below.
Okay.
But you remember we have an intercept, so it must touch that intercept.
Intercept.
Fine?
Yes.
Okay. Samsung,
Good morning, sir.
morning.
My question is, what if this other graph, I bring it the way you have brought it, but I cross it this line of y is equal to 3 and I stop it on 2.
Remember, I have told you that one, our graph does not cross the vertical asymptote. Vertical asymptotes is like a wall. They will never cross it.
Yes.
So it is a wall they don't cross.
What about this other
For horizontal, it is okay, they can cross it. But like we have said, like for horizontal, they can cross it, but for vertical, they don't cross it completely.
Sir, I'm meaning if I pass that curve here on this other two of the of the y-axis.
Which to here?
No, the other up one.
We're here.
Yes.
Which curve are you passing
This
here?
not immediately. I don't go beyond the vertical
Can you
asymptote.
write on my screen? You write on my screen. You draw that curve and I look at it. Let no one else draw. Have you seen the pen?
No, I have not yet.
What are you using? Phone?
Yes.
Are you using a phone, laptop? A phone. Check, there is a pen that appears somewhere here below your screen. You write on my screen and I see it. I don't know that I've not yet understood how your curve is going to look like. Uh,
Like there, sir.
like you
This.
bring your curve like this, eh?
It does not like here. That's two.
It does not?
It comes, but it stops here on two there.
On to here.
These two, where I'm fixing many lines here.
Here.
Yeah, yes, there.
Somewhere here. Like it comes like this.
Yes.
And it goes like this. And then it goes way up. Something like that.
Yes.
Okay. Okay, let me draw it. Let me show it to you how this thing looks like. And then you are going to visualize it maybe better. Let me draw it and then you look at it here. Okay, I think I'm going to clean my screen such that, okay, let me first clean my screen such that you look at it in a visual way, how it looks like. It was 3 3x plus 6 and then x minus 1. Have you seen it? Hope this is okay. So members, you can notice that how our curve is behaving. It is behaving like that. It is behaving like that. Then the other part, you are not seeing. It is, now the other part, remember it is asymptotic at 3. So at 3, it should just pass there, not touch it. So Samsung, I don't know whether you are able to see. I don't know whether the problem when I zoom it, you may not see the three. But when you look at it, let me see whether I can. Okay, I'm trying to zoom in. So where we have three, it should not touch, but it just appears. Because it must extend towards infinity. As it approaches the 3, it extends to positive infinity and then positive infinity along the y-axis. I don't know that Samsung you are getting it or not yet.
Yeah, I have understood, sir.
Okay. Yeah.
Yeah.
So visually, this is how it looks like on what? On the graph. When you draw it on the graph, it will look like that. Yeah. But for x-axis it appears like that. So you need to show how the curve approaches the asymptote, the horizontal asymptote, and you show because at asymptote, remember at asymptote, at the horizontal asymptote, we are looking at the behavior of the x value from infinity, from positive infinity. So how does it behave from positive infinity? Up and below. Okay.
Okay.
All
Thank you,
right.
sir.
Okay. Members, are we good to continue? Let me know whether we are good to continue. As I pick one hand. Yes, JHC. JHC.
So for me, I still have a challenge there on drawing the minimum and maximum points. How do we draw them on a graph?
Oh, now JHC, we have not yet obtained any maximum or minimum points for the graphs we have looked at so far. Because all of them didn't have a turning point. We only get maximum or minimum when we have a turning point. JHC, is that fine?
Yes, sir. Okay.
So we have not reached there, but we are going to look at one graph with that kind of thing. Okay, we can look at another graph. We can look at another graph. Another graph that I want to bring to your attention, we can look at y equals to x squared minus 4 out of x squared minus 4x. Hmm. Such, I want you now to look at the ones that are going to cross the axis, the asymptote, and what conditions are those where it crosses the asymptote. Eh, We are going to look at one with a turning point, and I want to show you one that crosses the asymptote and what conditions. JDC,
Yes, sir.
yes, first take us through the intercept. Let's go. Come back, come back. JDC.
Well, now, first of all, for the y,
Okay.
we're going to
Why?
say, then we're going to say when x is 0, then you're going to say y equals to 0 squared minus 4 out of 0 squared minus 4 into 0. So there we're going to have our y as negative 4 out of 0. The answer being negative.
So this is what?
Negative 4.
Negative 4 divided by 0. What do you get when you calc?
It's 0.
Hmm? Press it and you tell us. What do you get?
Math error.
Math error. So this is where you say no intercept. Is that fine?
Yes, sir.
Because this one is infinity.
Yes.
Then we go to the second one, the x-intercept.
X-intercept. There our is going to be 0. So we are going to have 0 equals to x squared minus 4 out of x squared minus 4x. So there x squared is going to equal to negative, is going to equal to 4. So our x will be 2.
When you square, how many values of x do you get here? When you get a root?
When you get a root of 4, we have 2.
We have positive and negative 2.
Yes, sir.
So what are our coordinates?
Our coordinates will be negative 2, 0, then positive 2, 0.
Okay. We continue, don't go away. We'll go to asymptote.
Well, the asymptotes will have the vertical asymptote. There we will have x squared minus 4x equals to 0. Then we'll have
Which
stuck.
kind of equation is this?
It's a quadratic.
So what do we do if we don't have a c?
We'll have x squared minus 4x plus 0.
So could you factorize from here now? Whenever your c is 0, you just factorize. JDC, come back, I've not released you.
Just some help there.
Factorize what is common here and here.
We'll have x into x minus 4 equals to 0.
Okay.
So we'll have our x equals to 0. Then we'll have x equals to positive 4.
Okay. We'll continue. When you look at this, which other asymptote are we getting?
We will have the horizontal.
Horizontal. What do you base on to say that it's going to be an horizontal asymptote?
Where that denominator, it's what I based on. The highest power in the denominator.
Okay. Because when you look at the denominator and the numerator, the highest power is 2 and the highest power is what? 2. So what did we say when the powers are the same for numerator and denominator?
We are going to divide by the highest power.
Okay. So what shall we have?
We'll have y equals to x squared out of x squared minus 4 out of x squared out of x squared out of x squared minus 4x out of x squared. So we will say as x approaches 0, there we will
Approaches what? Infinity.
infinity. So here the x squared out of x squared will be 1 minus 4 out of 0 out of infinity. Then divide by 1 minus 4, then out of infinity. So there our answer will be 1.
Okay. Okay. That's good.
Yes.
What next?
There, the turning point. So we will have y equals to x squared minus 4 out of x squared minus 4x. So here we are going to introduce ln. So I have ln of y equals to ln of x squared minus 4 into then minus ln of x squared minus 4x. So here we're going to have 1 out of y ln dy equals to 2x out of x squared minus 4, then minus, here we're going to have 2x minus 4 out of x squared minus 4x. So we are going to have 1 out of y dy equals to then there the numerator will have 2x into x squared minus 4x. Then minus 2x minus 4 into then times x squared minus 4 dy. Then 1 out of y dy dx will be 2x cubed minus 8x squared. Then minus, yeah, let me first see.
Judith.
Yes, sir. So
So
the
here you get 2x cubed.
2x cubed minus 8x, then minus 4x squared plus 16. The whole thing out of the other denominator. So from there, I think the 2x cubed are going to cast.
Then this is negative 8 plus 4x squared, which is 4x squared.
Yes.
Then plus 8x.
Then minus 16
Okay.
out of x squared minus 4. Then into x squared minus 4x.
Okay. I want to bring also the y this side. I have brought it
Then
x squared minus 4 out of x squared minus 4x.
yes,
So have you seen them cancelling? X squared
yes,
minus 4. So
yes.
up there, what do we remain with? Okay, let me write here. We remain with the y
Dy
dx.
x
Let me create. Continue. Dy dx.
it
Remember, as you
will
prove your answer, dy dx is equal to 4 something, 4x
it
squared plus 8x minus 16 out of x squared
of
minus
x squared minus 4x
minus 4x. But everything,
square.
we continue. About turning points.
Shall you help me from there?
No, like at turning points, dy dx is equal to 0.
Yes. So
Uh-huh.
if it's equal to 0, we'll have our 4x squared plus 8x minus 16 is equal to 0.
Hope you have
So,
understood why this one has vanished, right?
yes,
Okay. So here, just use the calc and tell me what you get. I don't know whether members are getting the same. Members, you let us know whether you have the same. It is a negative 4x. People are saying the 4. Oh, okay. Okay, let me go back. Let me go back a bit. Linda. Negative. This is negative 4x. Negative 8. Hey, this one here. Okay. Okay. This is negative 8x squared plus 4x squared. Okay, thank you. Hope members it is okay. This is supposed to be negative. Okay. Hope the rest are okay. Are the rest okay? Let us know in the chat. Are the rest fine? No. Jimmy says no. Jimmy, where is the problem?
Master, here where you maybe here where you introduce the lean, then you differentiated it for the first time. For me, I'm having 1 out of y divided dx is equal to x out of x squared minus 4 minus 2x out of x squared minus 4 again. Minus
When
4x.
you differentiate this, what do you get?
Sorry. Again, that is 2x minus 4. Okay, that's where I made a mistake.
Okay. Okay. Yes, it is fine. It is a negative 16. Okay. Okay. I think the rest are okay. Yeah. Members, are you getting any answer here? Which kind of roots are you getting?
we're
Which
having
you are
1,
having?
1,
Uh-huh.
and 1.
Can you look at your calc? Is your calc bringing R or something there? Look at it.
Yes,
Now that means that here we don't have roots. No real roots. Those are complex roots.
yes.
So that means that you cannot go any further. You can just end there because we shall not work with those complex roots.
Does that mean that there is no turning point?
Perfect. So here we shall not have a turning point.
Yes.
So this is not turning point. Okay, then we go to the last bit of it, x squared minus 4 out of x squared minus 4x. where the curve lies. Region where the curve lies. What do we do? Mm-hmm.
Wait, I don't recall.
We have looked at it today. Did you come late in lesson?
Yes.
Okay, okay. So there, to get the region where the curve lies, you equate the numerator and then the denominator to 0. So you just say x squared minus 4 equals to 0. So you have your x squared equals to 4. Get a root, get a root. So that means your x will equal to a plus and a negative 1, a negative 2.
Yes, sir.
Okay, then when you equate the other one, what shall we have? X squared minus 4x is equal to 0. Which answers shall we have?
We will have x into x minus 4 equals to 0. Then we'll have our x equals to 0, and then our x equals to positive 2, positive 4, sorry.
Okay. Then you can, members, like I told you, can first have this thing put on a number line where you have your negative 2. You arrange them very well. You have 0, you have 2, and you have 4. So that means that in your table that you are going to come up with here, you are going to have something negative 2 and less. How does my curve behave? That is x less than negative 2. What about between negative 2 less than x less than negative 2 less than x less than 0? What about between 0 less than x less than 2? What about between 2 less than x less than, less than 4? And what about above the 4? So you
4.
cater for all the regions. Is that fine?
Yes, sir.
Then here you have your y. Now, if you want, members, you can place this whole function onto your calculator such that you don't have to put values. You just put on your calculator. And let me hope we know how to place it on the calc. You know?
Teacher, which equation? The main one.
This one of y. So you get a value less than negative 2. Which answer do you get? Pick any value less than negative 2. Any of your choice.
If I use negative 3.
Now put it in the equation.
Well, yes.
So I don't know what you are getting, but I'm going to, you'll allow me for me to put what I'm getting. You can put everything on the calc. So here I'm getting something positive.
Yes.
When you put between negative 2 and negative 1, say negative 1, I'm getting a negative.
Then a
Put
positive.
anything between, yeah.
There it's a positive. There
Then the next
negative.
one.
It's a negative.
Here, is it a negative? Here, okay. Negative. Then the last one.
Positive.
Positive. Uh, so now this is the nature of our curve. So when we go back to our curve, we are going to, you are going to allow me to first know which values we are plotting. On our curve, we shall have values, the negative 22, then I have seen 4 and 1. Okay, it will fit. So I'm going to come on my graph here, and then we shall draw it. I'm going to draw it here. I think we don't have quite a number of negatives. Then I'll say this is 1, this is 2, 3, and 4. I have 0, -1, -2, -3, -4, 1, 2, 3, and 4, -1, -2, -3, and -4. So what was the turning points? -2, 0, 2, 0. Sorry, not turning points, intercepts. We had -2, 0 here, right? Then the other was it 2, 0? -2, 0 and 2, 0. Then next we had our asymptote. The vertical was x was 4. X was 4. So it means that that asymptote will look like this, to go through this. And this is for x is equal to 4. Then we had y was equal to 1. That one goes like this. Now, after getting that one, I'm just confirming y was equal to 1. We didn't have a turning point. So we are going to go on and look at the regions. When you look at the regions from here, we had negative. The first one was a negative. Oh, okay. So the first one was a negative. Sorry, was a positive. From a positive, it went on to become a negative, between -2 and 0. So that means that here, since your curve must pass here, it means that when you are sketching, you're going to come and do like this. It must pass through that. Then, between -2 and 0, still your curve, wait, I have to draw the vertical asymptote. We had it. Oh, no, we had one. We had one, right? Allow me to go back and first confirm. When it came to asymptote, we had another one. X was equal to 0. That was the second asymptote. I did not put it there. Allow me to include it here. This is the second one. Remember, we had it two. Remember, they don't cross the vertical asymptote. So when it comes here, we shall have something like this. That is for the first one. Between -2 and 0, it is still below. Then between 0 and 1, when you go back to your curve, between 0 and 2, your curve was positive. So you go back and ask, between 0 and 2, your curve was a positive. Then between your curve was a positive. Then when I go back, then between 2 and 4, it was negative. Between 2 and 4 was a negative. Now, you are going to understand that that curve, like I've told you, they can cross the horizontal axis. So between 0 and 2, it is a positive. Between 2 and 4, it is negative. So we have in between here, you have two lines. You have this asymptote and this asymptote. So to have that curve, you can have that curve come like this. You'll have something like this. It comes, I know this art of mine, but let me draw it again. So it comes like this. It does not touch the vertical thing. Then it comes, though it must pass through here, and it passes through there, and then it goes like that. That's how it can look like. Then the last one, above 4, it was positive. So above 4, it means that here it will come like that. So that's how you draw such a curve. Members, are we still together? No, here, Paul, there's no range. They have not asked us for the range. They have not asked us for the range. But we looked at the range yesterday. We looked at the range yesterday. Members, is this fine? How we come up with that graph? Okay, from the chart? Yeah. Okay. Yes, Baswali?
Teacher,
Yes.
there is where we were solving. For example, where we had x squared minus 4 is equal to 0.
Hmm.
What if for me I take the 4x on the other side and I have x squared is equal to 4x?
Mm-hmm.
Then I divide through by x
Mm-hmm.
and I get my x equal to 4.
Now that one, I would say you have missed out one value of which is x is equal to 0. When you look at this, the first thing always you ask yourself, it is a quadratic equation. And whenever you are solving a quadratic equation, we have methods that solve. Because x is equal to 4, it is right here. When you substitute in 4, you get 0. But there is another value which when you substitute in there, you get a 0. So x
Okay,
power 2 indicates that there are at least two values of x, which when you substitute inside, you get an answer. That's what you need to always have in mind. So you cannot only have one value.
the other thing is
Mhm.
I'm a bit confused on these graphs, teacher. I'm not understanding them very well.
Did you come in early or you have come in a bit late?
I came in something like 23 minutes past.
Oh, I think now that is where the problem is. But what now you can do, when it comes, you'll go back and review the recording. But we are building it. We are building the concept from what we started with on Wednesday.
Mm.
We are building the things now you need to know that you need to remember when we looked at the horizontal asymptote, we say that x approaches what? Infinity. So when you look here, this is taking you to infinity. When you look down, it takes you to infinity. Then you need to know the concept of an intercept. That when it comes to an intercept, is a point on the axis where our curve touches. So meaning that when you are drawing your curve, that point must be touched. Then we say that when it comes to an asymptote, the curve just passes, but it does not touch it. It appears to be very, very close.
Okay,
So
thank you, teacher.
that concept should come out that if you have this region here where they have told you it is above, then you need to know that this one goes to infinity and this one goes to infinity. That's why when we are getting the range yesterday, you remember, when we are getting the range and when we are getting the what? The domain. I was very clear. I told you now, for such a case, if now they want the range, you can easily notice that your range here for this particular one, for this particular curve, you notice that it is going to be above 1. So all values above 1 qualify. Then for this one, all values below qualify. But for this particular one in the middle, you notice that these values below and above can as well qualify. Okay,
Oh,
Paul.
thank
Morning, Mercy.
Paul,
Good morning, sir.
morning. Morning.
So I was asking about, because for us when we are drawing these curves, we used to get the empty sections and the regions of restriction for each curve that we are doing. So I'm not getting the kind of way that we are solving them.
No, it is the same way. I told you that what you call the region of restriction. Now, like for this curve, we can get that region of restriction, though I have not obtained it. But allow me members to take you back. I think we had a quadratic equation. This was a quadratic equation. Now, if I'm to find the region of restriction, remember our curve, like one, I want to bring to your attention that not all curves will have a region of restriction. That one, take note of it. Not all
Yes.
curves will have it. So some curves may have, some curves may not have. So you may find that all the curves for you looked at in class were curves that were quadratic in nature, that they did not give you any curve that was linear. Number two, when it comes now like for this, if I want the region of restriction, I'll come and I say y is equal to x squared minus 4 out of x squared minus 4x. Remember the region of restriction, we shall say b squared minus 4sc greater than 0. So
Zero.
I'll cross multiply, I'll have x squared minus 4x equals to x squared minus 4. So here I'll remain with yx squared minus 4xy equals to x squared minus 4. And therefore here, when I bring the x squared, I'll have yx squared minus x squared minus 4xy plus 4 is equal to 0. So what are you going to get here? We shall have our x squared into y minus 1 minus, this is 4, negative 4y x, then plus 4 is equal to 0. So when I come here, I will say b squared minus 4sc greater than 0. Our b squared, I will take the negative 4y squared minus 4 into a, which is y minus 1 into 4. So here you end up with 16 y squared minus 4 into, this is going to be 4y minus 1. Hope you are not seeing.
Yes.
So when you continue, you have 16y squared minus 16 of, that is what? 16 of y minus, which is a plus 4 equals to greater than 0. Can this thing be factorized?
Yes.
So when you factorize, what do you get?
Should I first reduce?
Okay, we shall have 2y minus 1 squared. I don't know that you're seeing that.
Yes.
Yeah? You reduce,
Yes.
you'll get something like that.
So now, master, is it not
So,
necessary to get the
so this is 2 minus
this?
1, 2 minus 1. Are you seeing it? Greater than 0. So that
Yes.
means that if you come here and you want to get such, you will first solve 2y minus 1, which is 2y greater than 1. Okay, y greater than a half. Now, when you look at a half here, can you obtain that region? You have only one value of y, which is a half. That means that you are going to look at, there is no, let me say, there is no range for such.
So,
I don't know that you have got it.
like, there is no range. There's no
Ye-
place where I can put a half.
No, like there is no restriction. In other words, there is no restriction. There is no interval.
Oh,
There is no interval. This is the same value of a half. So you cannot just say that the line is going to be a half. I don't know that you
yes.
are getting it.
I have got it.
So what I want to bring to your attention, when you are doing these things, not all curves have regions of restriction.
Restriction.
Not all curves have empty regions. It depends on the nature of the curve you are dealing with. Is that
Okay,
fine?
sir. Yes.
And that's why now it is always when you are at A level, go a step ahead. Read some textbooks, go beyond what the teachers have just given you. Go on and say, what about when I read this? What happens when it is? So you try out numbers. You'll find out that you are going to find those regions where the curve doesn't lie.
Thank you, sir.
Okay. Okay. Then lastly, I want to, but I don't know which time we have. Okay, let me know in the chat whether we can do one more of that nature that people want. We have two options. I'm going to give you the two options, but let him first speak, Elijah. But let me even show you how this graph looks like. Elijah, unmute.
Yes, teacher, good morning.
Morning.
Teacher, I was inquiring for a little pardon on these last two curves that we have drawn. The ones that had the interval of 0 to 2 and then 2 to 4 and lastly x greater than 4. I have not got the nature of how you've drawn the curve. I've got a little bit confused.
Okay. From 0 to 2, this part here,
Yes, sir.
they told us that your curve must be above.
Mm.
But still, between 2 and 4, our curve must be below.
Yes, sir.
But still, we have an intercept here. Are you seeing?
Yes,
Being
sir.
that we have an intercept, any curve we come up with must pass through that.
Yes, teacher.
Then you know that when a curve is approaching the vertical asymptote, it is asymptotic, it just passes there. And it just passes there. But I told that for horizontal, our curves can pass through, depending on how it is. That means that any shape you are coming with, it must pass through the intercept. So you ask yourself, how can my curve come out? When you have showed that it is approaching this zero asymptote and it is approaching the what? The 4.
Okay. Teacher, then the
Another
answer.
hint. Another hint you can look out for. When you look at that, okay, let me not give you that one. That one is enough. That one is enough. But
Yes,
I
sir.
don't know
Then the
whether you have
answer is
picked.
greater.
Have you picked a concept?
Yes, sir, I've got it.
Okay.
Then the one
Harmony.
for x.
Then the one for
X greater than 4.
x greater than 4. Here, you have this asymptote here. You have this asymptote here. Now,
Yes.
our graphs you must show that it is greater than 4. It must depict that it goes up to infinity. There is continuity. So you must show the continuity along the horizontal asymptote. You must show continuity along the vertical asymptote.
Okay, sir. Thank you so much.
So there is then a way, and now here, like there's then a way you are going to come and say, my graph is going to be like this. When it is like this shows you that your graph is going in negative, yet because it was x greater than infinity, the x and everything must be towards infinity, positive infinity, not negative infinity. Here, it is pointing towards positive infinity, but here it shows now negative what? Infinity, which contradicts that it was going towards the infinity, the behavior of your y values, that x is going towards infinity. Your y, because here, remember your y is pointing towards what? Infinity. When you get a value of x greater than what? Greater than 4. It means that your value x is greater than 4. It means that it is greater than 4 means any value above 4, which points towards infinity. Then when your y is positive, it is also pointing towards what? Infinity. So the only region that points towards infinity is this region pointing towards infinity and this one. When you come down, this one is pointing towards infinity, this one is pointing towards negative infinity, which contradicts. So that's why we put it up.
Okay, thank you, sir. I've got it.
Okay. All right. Harmony? Harmony, ask.
Good morning, sir.
Morning.
Good morning, sir. My
Morning,
question
Harmony.
is, under what conditions does the under what conditions does the curve cross the vertical asymptote? The horizontal asymptote, because it said in some cases it happens. So I want to know, when does it happen?
Now one, it will depend whether you have a region of restriction or you don't have. Secondly, it will depend on the positioning of the intercepts. How are the intercepts positions? And then 3, it will depend on the vertical asymptotes you have. I don't know that Harmony, that is okay. I repeat, it will depend on the vertical asymptotes you have. 2, it's going to depend It's going to depend on where is your intercept positioned. I don't know that is clear or not. Oh, I've not got harmony. Okay, but okay. Linda?
Sir, I'm confused from that curve, the second curve. You said the curve does not cross those asymptotes, but I'm seeing the second curve is crossing the asymptote.
I repeat, I said a curve
Yes.
may pass through the horizontal asymptote, but it does not touch, it does not cross the vertical.
Okay, thank you, sir.
Yes. Okay. 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 Maybe another condition to make uh, when you look at the value. Mm, okay. Yes, Julie, first come.
Good morning, sir.
Morning.
Shall I come? Like you answered someone and I wanted
Mm,
more clarity on. You say that towards the negative infinity, the
mm,
curve should tend towards the negative infinity, and then at the right it should tend towards the positive infinity.
mm,
That if it tends towards like to the right, if it tends towards the negative or it's below the x-axis, it will be contradicting.
mm.
Thank you, sir.
Okay, come again, come again. What was your question?
Okay, I was just inquiring, like it's like you said that
Mm,
towards the left,
mm,
the curve should tending towards the negative infinity.
mm,
Then towards the right, above the x-axis, the curve should tend towards the positive.
mm.
Yes,
Yeah,
that's what I got.
depending.
Is it?
Yeah, like I will give you an example for this particular curve whereby we had x less than negative thing. Now that one means that remember this is our asymptote. And remember we said when x was less than negative 2, you got your answer as negative. That means that any value you put in, it's going to be a negative. So any value this side is going to be negative. Then negative means your y was also negative, meaning that this is still negative infinity. So your y should also be going down. Are you getting it?
Yes.
Because your x value were less than negative 2, and values less than negative 2 can go up to negative infinity. And your y value got was also negative. So that means this is negative and negative. So it means it will be negative and negative. But if you had obtained, you had x less than negative 2, and your value of y was, let me say, a positive. Here it means that your x will be towards the negative. So that means that in case you are drawing your curve for such a case, here, somewhere here, it means that your x less than negative to your x will point towards the negative. But since your y, you have got it as the positive, for it is pointing up. So that means you'll have this one pointing this side, you'll have this one going where? Up. So your curve will come like this. Is that
Okay.
okay?
Yes.
Okay, now you just tell
Thank
me. Let me test your understanding a bit, Julie. Imagine you had your x greater than 2, and when for your values of y here in the table, you got your answers negative. You tell me, how do you think your curve will look like? These are our regions. This is your x-axis. This is my region A, this is my region B. In which region will your curve be?
Region B.
Region B. Very good. Because here your x is towards positive, it is going to infinity, so it will be like this side. But your y here you have obtained is pointing in negative infinity, so your y will point down. So your curve will be like that.
Okay. Thank you, sir.
Okay. Okay. Elijah?
Yes, teacher. I was
Hmm.
inquiring. You had told us about the title. I don't know.
The title just say a graph of y is equal to that, what you have drawn.
Oh, okay, sir.
Hmm. Okay. Then Kathy? Kathy?
Good morning, sir.
Yes, good morning.
Teacher, for me, I have a question. When we wanted to know where the curve lies
Hmm.
between -2 less
Hmm.
than x less than 2, when I inserted in -1 in our equation, I got a positive. But when I inserted in a +1, I got a negative. So I got confused. I was like, which of the two?
Come
How can
again,
you
come
get
again, come again. You are saying?
when you wanted to know where the curve lies
Hmm.
between -2 less x less than 2?
Less than
When
0.
2 in that
Uh-huh.
region, yes. When I
Hmm.
inserted in -1 in our equation, in the y equation, I
Hmm.
got a positive. But then when I inserted,
Let's insert in -1 squared minus 4 out of -1 squared minus 4 times -1. -1 squared is 1 minus 4 out of 1. -4 times -1 is a plus 4. So which gives us -3 out of 5. So this is negative.
when I inserted in a +1, I got, was it a negative?
But now have you seen that when you insert in -1, you get a negative?
Yes.
Uh-huh. So I think you made an error somewhere. Because even when you put in 1, you'll have 1 squared minus 4 out of 1 squared minus 4 times 1. So this is 1 minus 4 out of 1 minus 4. So this is -3 out of -3, which is a positive.
Hey, okay. I'm sorry, teacher. Thank you.
Okay. I think you check through and see. Okay. Baswali?
Teacher,
Yes.
when I'm drawing that curve, do
Hmm.
I base on this table?
Yes, this table is the one that helps you to know whether it is going to be above or below.
Okay, teacher.
Okay. Samsung?
Teacher, for me, I'm sorry to take you back. Mine is about the other previous lesson, because now here I'm confused about horizontal and oblique asymptote.
Hey, now, what I'm going to do also, why don't you allow me to refer you back to that recording? Because that one requires us about 30 minutes.
Oh, no, let's leave it.
It requires about 30 minutes to go back. But
And me,
what you have to do, you go back to that recording. You check out how we obtain, because those conditions are important for you. to know when the horizontal asymptote has three cases. So you need to know
Yes, I
what happens
noted
when
them.
you noted
For,
them, eh?
yes, I have them here. All the three have them. Only that I'm lacking the ones of oblique.
Oblique, it depends on the power. On the power. Let me first show people how this graph looks like. But still, I'm going to refer you there such that you can even try out some examples on finding those oblique ones. So members, you can
Okay.
check out. This is how that graph looks like. Now, you are going to allow me to ask, because we have not looked at some two. Okay, we have not yet finished. We need to look out to try out at least more graphs. So may I request that we create time tomorrow again, and at least we wake up tomorrow as our final day, and we look at least three graphs, whereby we have the graph where we are finding the region where the curve is restricted, a region where the curve is not, at least those ones. So, but however, for today's exercise, these are the curves you are going to sketch. That is one. Number two. Which one should I give you? Which one should I give you? Number two. Number two, I want to give you one. Hmm.
Hello.
And then another one, allow me to give you this 3x minus 9, x squared minus, wait, is it the one that I want? Wait to write, I want to see whether, this one, I don't,
Angie?
no, baswali, no, let me give you 2, let me give you y is equal to x into x minus 3 out of x minus 1, x minus 4. And I want to repeat for members that whenever you find that there is no region of restriction, that one is also a clear indicator. That one is also a clear indicator that your asymptote, your horizontal asymptote may be crossed. That is another thing. When you find that there is no region of what? Restriction, you will find that it is one of the indicators, but it's not the only thing. It's not the only thing. It's not the only thing. Okay, those are two. Should I give you one more? I can give you one more. Just, okay. Should I give you, okay, let me give you one. Then tomorrow we shall look at only two things. 4x, I give you what? 4x plus 5 out of x plus 3. Okay. Now, I don't know whether, do you want to first have a look at these graphs, how they look like, such that you mark yourself after finishing, or you want to draw and then you mark yourself? You tell me what you want. Should I first show you and then you know the kind of shapes you'll get, or better, we finish and then we mark ourselves? You tell me what you prefer. I'm going to look in the chat and I see what your suggestions are. Your suggestions help us. Okay, tomorrow is Saturday. Yes, Sabra, tomorrow is Saturday, true. Tomorrow is Saturday, true. But I have just requested for one reason, is that I want us to, we are almost ending the topic. So I just wanted us to first look at those two last, but I've not looked at the chat to find out what members are suggesting. So I'm going to look there and I see what your suggestions are. 2x minus 3. Your graph will look like that. So you have seen that one. I've plotted that graph. I'm going to delete. I'm going to delete such that you know how your shape will look like. So I'm deleting it. So when I delete it, I am going to draw the next one, x into O. But remember, even I had promised that I will show you how we draw these graphs. But I'll check out how our program tomorrow will be like. In case it favors us, we shall look at them. In case it doesn't, then maybe your teachers at your schools will show you. The second one, this one, will look like that. Hope you have finished that one. Then the last one is going to look like this. The last one will look like that. You have seen. Okay, I think this is enough for today. I've given you Ayobo all the cases where even it. Yeah, I've showed you all the cases where it crosses. So members, should we meet tomorrow or we end here? Okay.
Sir,
Yes. Okay. Ayoba, I've showed you how it crosses here. Yes, go on. Sorry, was it Jed's?
well, sir, I'm sorry to take you back, but about the other number that we just attempted, yeah?